A very good morning to Madam Aziel binti Muhammad Azizi and Mr. Azman bin Awangte. My name is Kishan and I am from 4BET S2/1. Today I will be presenting on my project titled as Development of Water Flow Management and Vector Control for Rainwater Harvesting Tank. Let me start my poster presentation with the introduction part at first. As we all know, 70% of the earth is covered with water. Even though the earth has an abundant supply of water, the supply of clean water is only 3%. Out of this, only 1% of water can be used because the rest water is in the form of ice. The demand for clean water supply is increasing double fast than the population. Therefore, it is more important to reserve water for human daily activities. In order to overcome vector infestation problem and smartly manage rainwater flow, a vector control and water flow management for rainwater harvesting tank prototype had been developed in this project. Now let's move to the problem statement part. Water shortage became a dominant issue all over the world. Even in recent times, Malaysia faces a lot of water shortage issues, particularly from the Selangor state. This happened because increased population and development increases the demand for water. Besides, El Nino phenomena is a natural phenomenon that causes impact on climate like increase in temperature and reduces the amount of rainfall. This will significantly reduces the amount of water. Besides, poor vector control in rainwater harvesting tank will lead to vector reproduction and later will lead to serious health issues to humans like dengue, malaria and yellow fever. From my research, I have found that dengue cases in Malaysia has risen from 72 cases for a population of 100,000 in 2001 to 361 cases for 100,000 population in 2014. Okay, now let's move to the objective part. The main objective of my project is to design and develop a water flow management and vector control system for rainwater harvesting tank. Second objective is to study the possibility of vector infestation in rainwater tank. Last objective is to analyze the performance of the developed prototype in terms of water inflow and vector infestation. Now let me explain the methodology part of my project. Below here is the flowchart of my project. My project starts when the rainwater is collected in the sump tank. Once rainwater is collected, meshing will be applied at the inlet and overflow, and Abate 1.1 G is poured weekly once into the sump tank automatically. This is the process done as the vector control method. Then, as for the water flow management, ultrasonic sensor will detect the water level in the sump tank and header tank at first. If the water in the sump tank is full and water in the header tank is full, water pump will be turned off and LCD display will show sump tank is full and header tank is full. It is for the condition 1. For the condition 2, where when the water in the sump tank is not full but water in the header tank is full, water pump will be turned off and LCD will display sump tank is empty. For the third condition is when the water in the sump tank is full and water in the header tank is not full. So, water pump will be turned on and LCD will display filled header tank and sump tank is full. And the project comes to an end. Now, let's move on to the results and analysis part. This is the first analysis. In this analysis, the presence of vector at sump tank was recorded for 14 days. The experiment was conducted with two different conditions. In the first condition, the experiment was conducted with a sump tank applied with vector control, while in the second condition, the experiment was conducted with a sump tank applied without vector control. From the pie chart, it can be clearly seen that in the sump tank with vector control, only 0% of vector present had been recorded, while for sump tank without vector control, 78.6% of vector presence has been recorded for the past 14 days. Therefore, it can be clearly seen that sump tank with vector control efficiently prevent vector infestation at the tank. Now let's move on to the second analysis. In this analysis, the height of the header tank is increased from 5 cm to 25 cm. Data is recorded for every 5 cm increment. This experiment was conducted to identify the efficiency of water inflow. From the graph plotted, it can be seen that the graph looks linear, where as the height of the header tank is increased, the time taken to fill the header tank also increases linearly. Therefore, it can be concluded that water inflow system work efficiently because the only factor that affects the water inflow system is the height of the header tank. In the figure 4 over here, the development of the overall vector control and water flow management system for the rainwater harvesting tank is shown. Now let's move on to the project potential of commercialization. This project has commercial potential to be purchased and used by consumer who faces regular water scarcity issue at the area. Besides, this project can be bought by consumer who have a rainwater harvesting tank without vector control, since this project would prevent vector from entering the sump tank or reproduce in the tank. Now let's move on to the conclusion part. By using this system, consumer able to store rainwater without any vector infestation problem. There will be no water wastage occur since rainwater is managed properly. Lastly, the primary objective was achieved, which was to develop a water flow management and vector control system for rainwater harvesting tank. Thank you. Today, I am going to explain about the demo of my project. Before move on to the demo of my project, let me explain the part of my project. The first part is the main system, which consists of LCD display, Raspberry Pi, and relay. The second part is the sump tank. The sump tank consists of inlet and overflow. Both the inlet and overflow have been applied with meshing. Even the top of the sump tank has been applied with meshing. Meshing has been applied to control the vector infestation in the sump tank. Inside the sump tank consists of ultrasonic sensor and water pump. Ultrasonic sensor is used to detect the level of water, while water pump is used to pump the water from the sump tank up to the header tank. This filter funnel design using the solenoid was designed mainly to pour Abate 1.1 G into the sump tank. This is a method to control the vector reproduction. Next, move on to the third part, which is the header tank. Header tank consists of ultrasonic sensor and durable silicone tube. Ultrasonic sensor is used to detect the level of water, while durable silicone tube is used to pump the water from sump tank up to the header tank. I'm going to explain how my project works for the situation 1, where the sump tank is empty and the header tank is empty. Okay, when I run the coding, it will automatically start to detect the level of water at sump tank and display the process at the main system, where it displays the sump tank is empty. Okay, now let me show how my project works. Before my project works, since there is no rain event occurs, I will be supplying the water from the pipe source. Situation 2, where the sump tank is empty and the header tank is full. The level of water can be seen at the Raspbian OS, where the logo volume indicates that the header tank is full. The level of sump tank or the process of the sump tank is only shown at the LCD display. Only the sump tank volume is shown because only the sump tank level of water is matters. Okay, now I'm filling up the sump tank to show how the project responds when the sump tank is full and the header tank is full. Okay, now I'm going to demonstrate my project for the third situation, where the sump tank is full and the header tank is full. At this situation, the LCD display will show the header tank is full and the sump tank is full, and the water pump will not be turned on since both the header tank and sump tank is full. Okay, now I am going to demonstrate the project for the fourth situation where the sump tank is full but the header tank is empty. Let's see what will happen when I run the program. Okay, the LCD will display sump tank is full and it will start to fill the header tank since the header tank is empty. Here we can see the header tank is being filled. Since the sump tank is full and header tank is empty, water will be continuously pumped until the sump tank is empty or the header tank is full. This is Abate 1.1G that will be poured into the sump tank weekly once to kill all the larvae that be produced by the mosquitoes or any vectors. The sump tank will be opened for 2 seconds to flow the Abate 1.1G into the sump tank. I'll be demonstrating how the Abate 1.1G will flow from the filter funnel. The Abate 1.1G flow cannot be seen clearly through the camera, so I will be placing empty container inside the sump tank to show the amount of Abate 1.1G that will be flow into the sump tank. So now I'm placing the empty container. So let's turn on the program to show the amount of Abate 1.1G flow into the sump tank. Okay, now let's see the amount of Abate poured into the sump tank. That is how much the Abate poured into the sump tank.